Good morning, everyone. Myself, K. Naresh Kumar, Assistant Professor of Mechanical Department, Anits Engineering College. I am dealing with the subject Design of Machine Elements. And in this lecture, we will see the following contents. Okay, the prerequisite subject knowledge that a student should have for designing a machine element, and what are the course objectives. The syllabus of Design of Machine Elements 1, course outcomes, and mapping of course outcomes with the program outcomes, and basic introduction to design, and we will see few applications, real-time applications where the design is very important. We will see one after the other in this course. Okay, the minimum prerequisite knowledge before designing a mechanical component, he should have strong basics related to few subjects that a student will study in second year, like strength of materials or mechanics of solids, and basic knowledge related to the mathematics and also engineering mechanics. So these subjects are essential before studying Design of Machine Elements 1 course. Why? Because he can apply the principles that what he studied in these subjects to the design of machine elements while he is designing that component. And what is the course objective? Okay, the main course objective to make the students to be competent in the field, to formulate a new plan or modify the existing design, and also determine the behavior of the components against various loads. Okay, the main intention of this course is to enable the student to develop a new product based upon the innovative ideas and based upon the skills that what he has gained through this course. The main intention is to impart innovative ideas through this course, such as decision making skills for designing various mechanical components. These mechanical components are generally used in automobiles or aerospace industries or for structural applications. And also through this course, the students should quantify the mode of failure, the material subjected to various loading conditions. Those loading, he need to analyze the behavior of that component against various types of loading conditions. Okay, and also he should find out the permissible stresses while he is designing that component. Okay, this is the course objective of this course, and through this course he will be able to achieve this objective. And if you see the syllabus of Design of Machine Elements 1, generally the student will study two courses, one in third year first semester, that is Design of Machine Elements 1, and another course, that is Design of Machine Elements 2, the student will study in third year second semester. In Design of Machine Elements 1, he will study about the basic design procedures and against static loads, fluctuating loads, and few mechanical machine elements design, whereas in Design of Machine Elements 2, the complicated parts, you will see the design, okay, related to the automobile. In case of syllabus related to the Design of Machine Elements 1, the first unit is related to the theory part, introduction to mechanical engineering design. He will study about the traditional design methods, such as design by craft evolution and design by drawing, and also he need to study about the what is the design process, how to design a mechanical component, how to determine the forces and what type of failures are there, and what are the design considerations that he should follow before designing a mechanical component, such as aesthetic considerations, ergonomic, manufacturing considerations, statistical considerations, and what are the industrial considerations. All these considerations you will see, and also how to designate a particular steel, BIS designation of steel, and he will be able to study about the mechanical properties a material should have. He will study in this course. Okay, all these parameters he will study in unit 1. And coming to the unit 2, It is related to the design against static load and design against fluctuating loads. In case of design against static load, whenever a component is subjected to a static loading conditions, how to determine the dimensions of the component under static loading conditions? Means here the load does not vary with respect to time, and the magnitude is constant and it is acting at a particular point, and it does not vary with respect to time. How the material is behaving with respect to that load, he will study in this design against static load. And in this, he will study about the whenever the axial load is acting on the component, what is the behavior. Whenever the bending load is acting on the component, what is the behavior. Whenever a twisting load is acting on the component, what is the behavior. And we will call it as he will analyze the component based upon the simple elementary equations like axial loading based upon the axial stress, bending loading based upon the flexural formula, and twisting loading based upon the torsion equation. And he will also study about the failure theories whenever a component is subjected to combination of loads. Means axial loading, along with that perpendicular to that another load is acting in the y direction, then how the material is behaving. Similarly, axial loading and y loading as well as shear loading, how the material is behaving. That is, we will see in theories of failures. Theories of failures are mainly applicable to different materials like ductile and brittle materials, what theory has to be applied, and how to determine the dimensions against combinations of loading. We will see design against static loads. In case of design against fluctuating loads, most of the components, whatever we are saying in our day-to-day life, are subjected to stresses like a repeated loading. If you take the actual service conditions of any mechanical component, then no component is subjected to a static loading condition. Therefore, determining the dimensions against static loading is very simple based upon the elementary equations. Whereas in case of a fluctuating load, whenever the component is subjected to a fluctuating load, we can analyze the component closer to the real-time applications. Okay, if you see any mechanical component under service conditions, it is subjected to a fatigue loading conditions rather than a simple static loading. Therefore, here in this fluctuation and fatigue stresses, we will study the concept of the endurance limit, up to which endurance limit is the point at which the material has to be designed against an infinite number of cycles. Means it is nothing but beyond that the material will gets fails under fatigue loading. There is an endurance limit we will study here, and how to design the component against fatigue loading based upon modified Goodman diagram we will see here. And we will also cover the Soderberg diagram and Goodman diagram, and what is the modified Goodman diagram generally we will apply for fatigue loading, and how to design the component and analyze the permissible stress against fatigue loading we will study in this concept. This is related to the unit 2. Now, unit 3 we will see about threaded and welded joints. Threaded and welded joints subjected to various types of loading conditions, whether it is axial loading, bending loading, or an eccentric loading. In case of threaded joints, we will see what is the efficiency of screw jack, power required for transmitting the force, and we will also see the torque requirement for bolt tightening, and also what is the efficiency of the screws and what type of screw threads are generally used to get more efficiencies. And we will also see about the single threaded screws and multiple threaded screws, and we will compare these two types of screw threads, and which one will gives you more power, which one will gives you more efficiency. And we will see few problems related to the all these threaded joints. Similarly, related to welded joint, depending upon the type of applied load, we will design the joint against various types of loading conditions, whether it is axial, bending, or an eccentric loading conditions. This is related to the third unit. And in case of fourth unit, we will see the design of shafts, keys, and couplings. Shafts are generally used to transmit power from one machine element to the another machine element. On the shaft design based upon the strength we will see, and also based upon the rigidity point of view. Based upon the strength, what equations has to be used, and how we will design the shaft based upon the strength, and based upon the rigidity, how you will design a solid shaft as well as a hollow shaft. And we will also see the concept of ASME code for shaft design, and we will see different keys design, and which keys are generally applicable, and which keys are more generally used in industries. And we will see various types of couplings, starting from rigid flange coupling, flexible couplings, and also we'll also see a spline. Spline is an integral part of the machine. It is like a coupling, it is like a clutch behavior. The clutch is similar to the spline. We will see all these concepts in fourth unit. The last unit is related to the spring design. This is widely used mechanical machine element in automobiles to transfer the motion from one element to the another machine element. Okay, in this spring design, we will see what type of springs are generally used and how to classify, what are the materials, and what are the structure of the spring depending upon the end formation, and how to design a helical compression spring, helical extension spring, and a torsion spring. And we will also see what type of coatings has to be employed on the spring to improve the reliability and reduce the corrosion. And also we will also see the multi-leaf spring design, how to design a multi-leaf spring used in heavy motor vehicles. And we will see the concept of nipping and short peening in case of multi-leaf spring. Okay, here in this last unit we will mainly concentrate on the helical springs, torsion springs, and leaf springs. These devices which are used for transferring the motion from one element to the another element. Okay, we will see all these concepts one after the other. And the textbooks that I heavily rely upon is V.B. Bhandari textbook, Design of Machine Elements. And in addition to the textbook, okay, you can also follow these reference textbooks. And in these reference textbook, one is Machine Design by Jain Khanna Publications, and Machine Design by R.L. Norton, Machine Design by Mechanical Engineering Design by Sigley and Pandya and Sa. Okay, in second textbook and third textbook, okay, you can heavily rely upon as a reference. Why? Because these two textbooks are good textbooks. Okay, you'll get good information in this textbook. And the web resources nptel.ac.in as well as other web resources are given for your reference. So this is the syllabus of Design of Machine Elements 1 course. Now, what is the course outcome of this Design of Machine Elements 1? Okay, we have divided into each unit, we have divided into one course outcome. Therefore, here we are having 5 units and we have divided into 5 course outcomes. And at the end of this course, the students will be able to learn through first unit. You can have a knowledge related to the understand the procedure of designing a component, taking into account of all the material properties and design considerations. And through unit 2, he can analyze the type of failure and determine the geometrical dimensions against different types of loading conditions like static and fluctuating loading conditions. And through unit 3, he can evaluate the stresses induced in welded joints as well as in the threaded joints subjected to different types of loadings, whether it is maybe eccentric loading or a fluctuating loading. And through unit 4, he will be able to design a shaft, key, and coupling depending upon the type of loading conditions and whether induced stresses, and considering the factor of safety also. And through unit 5, he will be able to design the springs subjected to various types of static and dynamic loads. So these are the 5 COs the student will be able to achieve after learning this course. And here we are mapping the course outcomes with the program outcomes. Whatever the course that a student is learning is mainly we should reflect through the program outcome. Okay, this course outcome has to be mapped with the program outcome, then only the ultimate goal can be achieved. Here we are mapping with the program outcomes. Here the program outcomes are generally divided into 12 program outcomes, PO1 to PO12, and below that PO12 you are having PSO1 and PSO2. That is program specific outcome 1 and program specific outcome 2. Combining the program outcomes of 6 you will get PSO1, and combining from 7 to 12 you will get PSO2. These are not generally applicable to the course. Okay, for few courses if you wanted to combine the program outcomes, then we will assign the program specific outcome for that course. And generally this is applicable for only for few courses, but for our course we are dealing with the program outcomes of 1 to 12. And if you look at the program outcomes, each program outcome will give you a specific intention for the student to achieve. Here for the PO1 is related to applying the knowledge of mathematics, science and engineering principles and also the fundamentals, okay, for all the mechanical engineering problems. Okay, here the PO1 is related to, he should have the basic knowledge related to all the subjects, and the PO2 he should be able to identify, formulate as well as analyze the problems for designing a mechanical missing element, and PO3 is related to the design of the mechanical systems concerned with the processes in the fields of all the subject knowledges like manufacturing, industrial and mechanical design. Okay, here the PO3 is related to design of mechanical system components. Therefore, our subject is related to the design of machine elements. Therefore, here all the COs are highly related to the PO3. And the PO4, PO5. PO4 is related to the research methodology, and the PO4 is related to the research methodology. PO5 is related to the select and apply appropriate latest technology if you wanted to use latest technological tools like simulation and everything, then PO5. And PO6 is related to various societal issues, and PO7 is related to the whatever the designing you are, that should be in eco-friendly in nature. And PO8 you should follow certain professional ethics. PO9 you should function effectively as a team, and PO10 you should communicate effectively in a team. PO11 and apply the knowledge of engineering and management principles. PO11 and PO12, okay, always you need to realize and engage yourself for the lifelong learning process. So these are the general PO1 to PO12. Okay, all the POs are will not be applicable to the each course outcome. Okay, we should map based upon the high level, medium level as well as low level. Okay, high level we are giving as 3, and medium level we are giving as 2, and low level we are giving as 1. Okay, now I am mapping all these COs with respect to the program outcomes. Suppose if you see CO1, for PO1 I am mapping as 2, means it is medium. PO1 it is medium for the CO1. Medium means here we are applying the knowledge of mathematics and all the subjects like science and engineering principles that a student is studying in his course. He will apply that knowledge for designing a machine element. That's why I'm giving as PO1 as 2. And PO3 designing a mechanical system. Therefore the CO1 is highly related to the designing a mechanical system. That's why I gave as 3 as high standard. PO4 and PO5 I am giving as some 2 levels. Why? Because PO4 if you see apply the research methodology for design and analyze. Therefore here it is related to we are applying the research methodology techniques for designing and analyzing the component. Therefore I am giving as some moderate level as 2. And PO5 again we are applying some software tools for analyzing the behavior of the component. Therefore I am giving as 2. And PO12 if you see you should always engage yourself for lifelong learning process. I'm giving as low level 1. Okay, if you see the mapping of course outcome 1, high level 3 is given to PO3. Okay, if you see, depending upon the each course outcome, you can map the course outcome with the program outcomes, and you'll get a table like this. So this is an overall view. That's I wanted to give an idea for you how the course outcome is mapped with the program outcomes. Okay, if anyone asks you, you should be in a position to explain to them how it is mapped and what are the various program outcomes. Okay, at least you should study related to your course. Okay, what is your course and what COs are generally mapped with the program outcomes. Now if you see the introduction to design, now into the introduction part for the design course. Okay, in this lecture we will see the introduction to design and what is meant by design. Oh, generally if you see, design is nothing but, in case of Latin word we will call it as a designate. Designate is nothing but to mark out or a plan, to invent, to contrive, to conceive. Okay, all these terms are iterative terms related to the design. Okay, whatever you are designing, it should come from a plan. Okay, you should have a certain plan. You should formulate a plan for the satisfaction of a specific need, okay, or to solve a problem. And the plan results in the creation of something which is having physical reality. Okay, after planning, whatever you are creating, it should have some physical reality, and the final outcome of the product should be functional. It should be safe, reliable, marketable, competitive, manufacturable. Okay, these are the terms associated with the design. And what is the role of the, if you see the examples, the automobiles are designed, wallpapers are designed, clothes are designed, and the aerospace mechanical components, many many things around us, from household appliances to large components like aerospace applications, gas turbines, turbojet engines, cryogenic engines, all those are related to the design. Whatever you are designing, you should have a specific knowledge and also why you are designing that component. Mechanical engineering design, what is the role of mechanical engineer in case of design? The main role the mechanical engineer is in the case of production as well as the processing of energy. The main intention of the mechanical engineer is that whatever the subjects he's learning, like strength of materials, mathematics, fluid mechanics, heat transfer, he will apply all those principles for designing a component, and that component should be in physical reality. Therefore, the role of mechanical engineer is he should apply all the scientific knowledge or principles that what he has learned through all these courses like mechanics of solids, mass momentum transport, etc. And he need to design the component. That is the role of mechanical engineer. Oh, what are the skills that he should require while he is designing a component? One is he should be innovative. Decision making skills are very much necessary. Problem solving roles and communicative ability. These four skills are very important before designing a mechanical machine element. Well, these are the various mechanical machine elements I have given just to have an idea. Related to the automobile, I have given a shaft, screw fasteners, welded joints, springs, bearings, gears, clutches, brakes, couplings, flexible machine elements, belt drives, flywheel, wire ropes, etc. Yeah, all these are mechanical machine elements. Okay, knowing of the design procedures and identifying the failures, determining the dimensions is very much essential for the designer. He can apply this knowledge in real-time applications. And whenever we are designing a component, the main parameter that we will see is determining the fracture behavior of that component. Okay, this can be achieved, okay, whatever the courses that you have studied or you have learned in strength of materials are very much useful. And the idea that was emphasized was that whatever the knowledge that you have gained is very, very limited. Suppose if you wanted to characterize the material, and one of the tests that you can use is a simple tension test. Okay, what is the tension test? The main focus of the tension test was you will have an elastic region followed by a large plastic zone and then only the material phase. But once people had moving parts in the design like locomotives start failing, people felt that a simple tension test is not sufficient to characterize the material completely. Something more needs to be done. And this prompted to design a new test called as fatigue test. And in case of fatigue test, the main focus is to find out, apply a repeated loading on the specimen, and the test was confined to measuring only the number of cycles when the test specimen fails eventually. Okay, you do not require any other information to record separately. It is an improvement from the tension test. Okay, in service conditions, you will have a repeated loading and you will be able to simulate that repeated loading and also perform the test until the specimen breaks. So you collect voluminous data and this data is represented in a nice form for you to process. And you will plot a SN diagram, a log paper on a log paper, plotting the number of cycles on x-axis and the stress amplitude divided by ultimate strength on the y-axis. And based upon this data, you'll get various scattered points which indicates various experiments that are being performed on that specimen, and based upon that you will get a line that will give you the least expected life for given alternating stress. You will have a convenient parameter in case of fatigue test. You will have an endurance limit, and if you load the specimen up to endurance limit, you have infinite life without any problem, and beyond that the failure will take place. And if you see the modern research, it tells that there is nothing like endurance limit for any material. Every material will fail after sufficient number of cycles, and you will correlate this endurance limit determined through experimental test with respect to the ultimate strength of the material, and it is generally a steel, and generally the relation is SC dash equal to 0.5 times of SUT. Therefore, whatever the development of SN curve for designing these structures, has recognized the crack growth, but it has no provision to monitor the growth of crack. Therefore, you will have two tests here. One is tension test and fatigue test for determining the failure of the component, but you cannot monitor the growth of the crack. You need fracture mechanics methods for determining the behavior of crack growth. Okay, this is related to the determination of fracture through tension test as well as fatigue test. Now, in these approaches, we'll call it as a conventional design approach. In this conventional design approach, the material can be designed based upon the strength and based upon the stiffness.